There are many resources available to perform diagnostics and debug your MicroWin project. First is to compile and view the information window. Here's where errors are documented. If you happen to have an error, all you have to do is double-click on the error, and it places the square cursor directly over the error. Here we see I'm trying to evaluate a byte, and in the operand I have the value of a word. So let's correct that and make it a B for byte. And now when I compile, we see no errors. Also, you can see your variable usage as well as your memory mapped in cross-reference. Here in the byte usage, you can see that the capital B uses the entire byte, while lowercase b only uses bits from that byte, while VB10 is a double word in length, while VB0 is a word. In the cross-reference tab, you can see the elements that are used within this project. You can see the block, location, and how it's used. For example, I0.7, the 8th digital input, is in network 8. When it's normally open, I can double-click it, and it'll take me directly to that element. A very useful tool can be found on the menu bar under the PLC selection. Compare will compare your current project in the program editor window with the project that's in the PLC. And the program block will compare the logic, while the data block will compare the user-defined values and the wizard configurations, and the system block will compare the PLC configuration. And here we see that there are many differences in the program block, as well as a difference in the PID wizard configuration. So let's make the program editor match the PLC by downloading this project. We're prompted to put it in stop before we download. And we see our download was successful. Other resources available on the menu bar can be found under the debug selection. We have first scan and multiple scans. Scan functions. The first scan will execute your logic for one scan, while multiple scans will execute your logic for a predefined number of scans. These functions can only be performed with the PLC in stop mode and the mode switch in the terminal position. So let's do multiple scans, and let's do 600 scans. And here on the other page, we have the rack status page of the IT module, CP243-1IT. And when we refresh, we can see that the PLC is still in stop mode from the download. So let's execute the 600 scans. And when we refresh, we see that the PLC is in run mode, but only for the 600 scans. And after the 600 scans are completed, we see that it transitions back to stop mode. So only 600 cycles were executed just as desired. Other selections include program edit while in run mode and write and force outputs while in stop mode. To utilize these functions, one must check this selection and download the project one last time while in stop mode. Once the PLC is updated, only then program edit and run and write and force outputs while in stop are enabled. The rest of these selections can be found here on the debug toolbar. So let's put our PLC back into run mode with the green triangle here. And let's monitor the flow of current through our circuit with program status icon. Now we can freeze the display by using the pause program status icon. Please note that the pause program status does not pause the execution of logic in the PLC, it merely freezes the display. Now we can work with these padlock icons over here. These are the force icons. By selecting an element, you'll notice that the force icon is now enabled, or you can right-click and select force. So let's write this input by making it the value of a 1 and force that input, and you'll see that it turns on, and you get the icon of a little padlock showing that it's forced. So this contact is written as a close at the beginning of each scan cycle. So here we see that the unlock icon is now enabled, or of course the unforce all is always available. And now let's simulate a condition by writing. We will write the hold-in contact and simulate it opening by making it open with the value of a 0. And when we write that, we notice that it opens the circuit and the coil is de-energized. So rather than navigating through every program operating unit to monitor inputs, outputs, and process variables that are important to you, you can gather them all into one location, and we call that a status chart. You can access the status chart with this icon on the debug toolbar, or of course you can always look under View, Component, select Status Chart, as well as it's always available on the navigation bar And here in the folder tree, you can see that we have two status charts created, one called color, one called fan. So let's work with the one called fan. Now to work with this, we can use this pair of glasses, and this will populate the cells on this status chart with the values from a single scan cycle, while this icon here will continually update with current values. Now rather than watching numerical values, you can have those values graphed over time by using the trend view icon here on the end. Now using the trend view, you can see what the values are over a period of time. And in order to give us a little more room to view, we can hide the folder tree, and we can also hide the navigation bar. Now, in order to change the increments for view over time, you can change the time base by right-clicking, selecting time base. Now let's make this once per second updating. You can also write and force values from this screen. Under set point, we will right-click, select write, and we can make the new set point of 7,500 RPM. And we will see the set point adjust as well as the PID output percentage, and we will see the RPM respond as well. Now that you can write and force from this screen, you can write to simulate a set of conditions, or you can force vMemory, mMemory, analog inputs, and analog outputs. When you force a value in your program, the operand is effectively reset to the forced value with each scan cycle. Please use the force feature with caution, as it may cause your program to execute unpredictably. Writing is also possible from the standard status chart screen. For example, we can rewrite the value by 6,000 for the set point and use the pencil write all icon. We see that the value has now been updated. This chapter we have covered information window, debugging menu and toolbar selections, program status, forcing and writing values, status chart, and trending.